In this lecture, we're going to focus on the micronutrients that include the vitamins. Vitamins, because they're micronutrients, along with the minerals, do not provide any energy. Your macronutrients, fats, carbs, and proteins, as well as alcohol, give you calories. But vitamins, while they're certainly important in helping you utilize the calories from the different parts of your diet, you don't actually get calories from vitamins. When we use the term micronutrients, what that refers to is that your body needs them in smaller amounts than it does the macronutrients. Smaller amounts refer to the units milligrams or micrograms. The non-energy yielding nutrients, the vitamins and the minerals, you find them in amounts in your foods in very small amounts. Again, milligrams or micrograms. As compared to those macronutrients, remember you find those in your food in larger amounts, which are grams. Vitamins are classified by their solubility. We have fat-soluble and water-soluble vitamins. The fat-soluble vitamins include vitamins A, D, E, and K. The water-soluble vitamins are the B vitamins, as well as vitamin C. Vitamins are organic compounds that are essential in our diet. You've got to eat them in your diet because your body lacks the ability to make almost all of them. They help promote growth and maintenance, and they're helper nutrients. They allow your body to do things and nutrients from other parts of your components of your diet to do their job. The B vitamins, which is a group of vitamins, was originally thought to be just one chemical substance, but further research showed that there are actually many different substances. To some degree, they have some similar actions, so they work together as a unit, but there are a number of different B vitamins as well. The B vitamins plus vitamin C comprise the water-soluble vitamins. One very important thing that some vitamins do is they provide or they can give antioxidant functions in your body. Antioxidants work by helping to neutralize free radicals and stop the process of oxidation. Both of those are bad things. You can think of the free radicals as bad guys, and oxidation is a bad process. In the top, what we have are free radicals. The free radical is actively looking for an electron or from another compound. Unpaired electrons in the outer shell promote unstable free radicals. So we want to stabilize these bad guys so that they can't do oxidative damage to our bodies. Antioxidants, and some vitamins act as antioxidants, they donate an electron to help stabilize the free radical. And what happens then is that stops the process of oxidation, what's known as antioxidants. A little bit more about free radicals. Some free radicals can actually be helpful. Your immune system uses them to destroy disease-causing microorganisms. White blood cells may produce them to destroy things like bacteria and viruses. And some free radicals may even help your body destroy dead cells, which some researchers think may help to prevent certain types of cancer. For the most part, though, we think of free radicals as being harmful. They cause the loss of cell membrane integrity, and they cause your cells to collapse. They damage LDL and plaque and can cause atherosclerosis. They also result in DNA alteration that results in altered protein synthesis that can cause a whole host of diseases and disorders. So for the most part, we want to avoid the accumulation of free radicals in our bodies. From a disease standpoint, free radicals have been linked to conditions like cancer, emphysema, cataracts, atherosclerosis. We also have environmental factors that we know increase free radical formation. So if you smoke a lot of cigarettes, if you have excessive sunlight exposure, exposure to too much radiation, asbestos, or toxic chemicals, in addition to dietary components, this can increase the free radical promotion in your body. Some of the nutrients with which researchers have discovered that have antioxidant roles include vitamins A and the carotenoids. So if you've heard of beta-carotene, that's an example of a carotenoid. Vitamin C and vitamin E, as well as the mineral selenium and certain types of phytochemicals. And phytochemicals are compounds that we find in plant foods. We'll look at those more closely when we look at the role of cancer and diet. So the three vitamins, you see the first three listed here, vitamins A, vitamin C, and vitamin E, are vitamins that we know have antioxidant roles. They do a lot of other things, but they also help work as an antioxidant. So to show you an example here, The free radicals are the three yellow and green compounds that you see at the top. Okay, so these are our free radicals, these guys up here. They're unstable, they've got that unpaired electron, and they're floating around looking to do damage. On the left-hand arrow, what you see here is the free radicals are damaging the DNA and other molecules. But when vitamin C shows up, vitamin C donates one of its electrons to this free radical, which causes that free radical to be stabilized. And it helps over here to prevent the damage to the DNA. Vitamins have differing levels of bioavailability. You might eat something that has a whole bunch of vitamin C, but you might utilize a different amount of that than I would, even if we're eating the same foods. Vitamins have to be absorbed by your body in order to work. 40 to 90% of vitamins are absorbed in the small intestine part of your GI tract. The fat-soluble vitamins require that you have some fat in your diet in order for them to be appropriately absorbed and transported. Water-soluble vitamins may require transport molecules or other specific molecules in your GI tract. Some vitamins are actually formed in their inactive provitamin form, or they might be absorbed in the vitamin precursor form that have to be converted in your body to an active form. But the bottom line is that there are different components that affect how much of a vitamin is available to be absorbed and appropriately utilized by your body. Let's take a look at a very well-known vitamin, vitamin C. Vitamin C is also called ascorbic acid, and as you learned, it has antioxidant properties. Vitamin C plays an important role in helping make collagen that helps to promote wound healing. So sometimes when you see individuals who have bed sores or wounds that are not healing very well, they might be prescribed to take a high-dose vitamin C supplement to help promote the repair of that collagen and the healing of that wound. Another interesting thing that vitamin C does is it helps you more readily absorb iron. So iron is a mineral, and if you eat an iron-containing food alongside a vitamin C-containing food, you'll actually absorb more of the iron from the iron-containing food than you would if you didn't consume the vitamin C food with it. A good example of that is if you have an iron-fortified breakfast cereal. Let's say some sort of bran flake cereal that has iron in it. If you have an orange or a little cup of orange juice in addition to that cereal, you'll absorb more of the iron from that cereal. Another thing that vitamin C does is it helps to promote a healthy immune system. Now, for the most part, this is a good thing, but it's kind of skewed off in that many people think, well, if I take a lot of vitamin C, then I'll have a very, very healthy immune system. And that's not necessarily the case. If you don't get enough vitamin C, your immune system will be compromised. But taking loads and loads of extra vitamin C won't help prevent a cold or make you not get sick. Because it's a water-soluble vitamin, you'll just end up urinating out the extra vitamin C that your body doesn't need. Sometimes for people who take a lot of expensive supplements that are full of water-soluble vitamins, we say, oh, those people just have expensive urine. They're paying a lot of money for supplements that they just end up urinating out. If you take very high doses of certain supplements, including vitamin C, it can lead to some negative side effects. High doses of vitamin C, it's an acid-based vitamin, so it can actually be a little bit caustic to your GI tract. In some people, it can cause diarrhea and an upset stomach. Perhaps you've heard of the name of the vitamin C deficiency disease. And I show you some teeth here because it's a clue that the answer is scurvy. The name ascorbic acid actually is a tribute to the role that vitamin C plays in helping to prevent scurvy. Hundreds of years ago, before vitamins were isolated, sailors who crossed long periods across the ocean learned that if they didn't have any fruits or vegetables, their teeth would fall out. They didn't know what that was attributable to, but when they started including citrus foods in the diet, their teeth didn't fall out. So there was something in the citrus foods that was helping to prevent scurvy. And what they first called that was the anti-scorbutic factor, meaning the anti-scurvy factor. And when vitamins were eventually isolated, vitamin C was called ascorbic acid because of its historical contributions to helping to prevent scurvy. You get vitamin C, as you probably know, from different types of citrus fruits. But all fruits and vegetables have some degree of vitamin C in them. Some fortified foods do as well. Sometimes manufacturers add extra vitamin C to foods. Adult males are estimated to need about 90 milligrams of vitamin C a day, and females need slightly less, 75 milligrams per day. Although there are other nutrition recommendations that say that the vitamin C needs are a little bit higher. These are the United States recommendations. What's interesting is that smokers need an additional 35 milligrams of vitamin C per day. And you see the antioxidant effects there, that the tobacco smoke, which is oxidized in the lungs, a little bit extra vitamin C is helpful for those individuals. There's an upper safe limit of 2,000 milligrams per day because it can cause GI distress. Some of these anti-cold things that you see out there might have 2 or 3 or 4,000 milligrams of vitamin C a day. For most people, it doesn't cause any harm, but for some people, it can upset their stomach. What else does vitamin C do? Well, it might play a role in cancer prevention. People that eat diets that are high in fruits and vegetables tend to have higher vitamin C content of their diet than other heavy meat eaters do, so it might help protect against cancer. People with higher intakes of vitamin C containing foods have lower rates of heart disease. It also may help protect against age-related macular degeneration. But the question that I know you're all waiting to hear is, does vitamin C help with the common cold? Vitamin C supplements do not reduce your risk of getting a cold, but they may help reduce the severity and the length of the cold. So once you're already sick, if you're taking vitamin C, it might make your cold less in length and might make it less intense for you. But taking high doses of vitamin C supplementation has not yet been proven to help prevent colds. Because there are varying levels of vitamins, and some of these are very sensitive to heat and light and cooking, here's a couple of tips for you to help preserve the vitamin content of the foods that you eat. You want to store your fruits and vegetables away from heat and light, and to try to eat them as soon after purchasing as possible. Cut your fruits and vegetables as close to the cooking time as you can. So if you're going to make a soup, don't cut up your broccoli and your carrots and your peppers hours before, because as it sits there exposed to the light and the oxygen, it may reduce the vitamin content. Try not to soak your vegetables if you can, because the vitamins may leach out of the vegetables and fruits into the water. Cook in as little water as possible, and try methods such as microwaving, pressure cooking, roasting, grilling, as opposed to baking or boiling. Those baking and boiling tend to increase the amount of vitamin loss in the foods when you cook. You can actually use the water from your cooking vegetables in order to make soups and sauces, because the vitamins that leach out of there are still usable, and if you can put it back into the food, then you'll be actually increasing the vitamin content of your foods. Lastly, for things like rice, unless it's pretty dirty rice, you want to try to avoid rinsing rice before cooking, as it has the potential to wash away water-soluble vitamins. If you're interested in learning more about vitamins, you might check out some of these websites from the Harvard School of Public Health, the Food and Agricultural Organization, and the U.S. Library of Medicine.